I'm not a car expert, and most of what I know about nitrous is from watching one of the first few Fast and Furious movies. So if you're a car expert and I'm not saying this right, bear with me a little bit here. It's just a metaphor. So whenever we're in a race and we have a car that has nitrous, then from my understanding, you press the little red button, and this gives us a significant increase in the amount of power output that car is able to produce. So it's able to go much, much, much faster. And this is how creatine works. So it gives us that short-term energy storage for when we need to do very intense exercise. Welcome to the Art of Prevention podcast. I'm your host, Nicholas Hedges, and today we are doing a deep dive on one of the most frequently asked about things so far since the onset of this podcast, and it might not be what you're thinking of. Today, the deep dive is on creatine. So creatine is a supplement that many people take. When I was in high school and things like that, I was a distance runner, so I never took any creatine. I do take creatine now, and ironically, regardless of where I'm at, regardless of where I'm speaking, what population I'm talking to, I get many questions on creatine. And some of the questions include, is this beneficial for me? How much should I take? How should I take it? Etc. And these are all answers or questions that we will hopefully answer for you during this deep solo dive today. So let's dive in. The first thing that we need to ask is, what is creatine? So creatine is a molecule that's formed by 3 different amino acids. Those amino acids are glycine, methionine, and arginine. And these 3 amino acids come together, and what they do is they hold on to inorganic phosphate. Well, who cares about inorganic phosphate, right? Inorganic phosphate is very important because phosphates and the breaking of the bonds to phosphate and ATP and ADP are how we store and release energy within our body. So we're going to have to talk a little bit about energy systems during this podcast, and we're going to have to talk about how we create and utilize energy within our bodies. Now, creatine is also really nice to do on a podcast because it's one of the most researched ergogenic aids that is in existence today. So it has the most research supporting it. There are literally hundreds, maybe even thousands of trials and research papers that back up the utilization of creatine and have looked at the utilization of creatine and its effects on many body systems in many different special populations and in many of the mechanisms as far as how and why it works. So back to what creatine is. Creatine is how we can store accessory inorganic phosphate groups so that we can recreate adenosine triphosphate, and it's stored largely in our muscles. So over 95% of creatine is stored within our skeletal muscle. So inside the actual muscles that are producing work. Now we also get storage in our liver, and we even store it in our brain. A little bit is circulating within our blood, and then other accessory organs such as the pancreas and the kidneys. Now, creatine is something that is endogenously produced as well. So if we're looking at the safety and efficacy of creatine, we have to recognize that it is, of course, safe because our body does produce it on its own. So the majority of our creatine that's produced endogenously, so the majority of the creatine that's produced in our body is produced inside of our liver, and a little bit, a tiny percentage, is produced in the pancreas and the kidneys. Now, when we take creatine, we are taking it exogenously, hopefully orally. So hopefully you're taking creatine, usually mixed up in a little bit of water. We'll talk a little bit later about other means by which you can take creatine, whether it's good to take it with a little bit of glucose or sugar in order to get it into the muscles faster, etc., or if you need to do that. And we'll also talk about optimum dosage later as well. So creatine is something that is produced within our body, and actually our neurons also synthesize creatine. So the brain and other tissues that utilize a lot of energy and have a lot of fluctuations in energy utilization rates, these are oftentimes tissues that will store high amounts of creatine. So our brain has creatine in it, our muscles have creatine in them, our liver has creatine. Basically, every structure of our body is going to have some semblance of creatine utilization. And when we look at some of the different forms of creatine that naturally occur within our body, such as phosphocreatine, so creatine with that phosphate group, phospholipids create our cell membranes, and thus creatine can actually attach onto the cell membranes of many of the cells of our body. Now, in that scenario, they're not typically used as energy producing substrates, but this is just going to show that creatine can attach to and be utilized throughout the body on almost every single cell. And indeed, there are studies that link it to the utilization in many different locations and areas in the body. And not all the time is it always used for energy, but it can be used for other things as well. So what does it do? So as stated previously, creatine can help shuttle and help store those high energy phosphates. And when we do that, creatine is stored as phosphocreatine. And creatine is present in our body in three major forms: phosphocreatine, creatine, and creatinine. And the inine portion, the very end of that line, is important because creatinine is the waste product from normal metabolism of creatine. So whenever we have the high energy state of creatine, that means that we're dealing with phosphocreatine. So PCR is the shorthand. And we can utilize PCR to hold on to that phosphate group for when we have a large fluctuation in energy like we talked about previously. So our brain tissue, our cardiac tissue, and our muscle tissue will oftentimes have these big fluctuations in energy utilization. So right now I'm sitting down, but me moving my arms, me if I have to stand up, or let's say I'm weight training, or if I'm doing some sort of power-based training or sprint-based training, or me, I'm a rock climber, so if I'm out bouldering, then the utilization of energy in my musculature and even my neural tissue is going to fluctuate based on if I'm at rest, sitting, or if I'm performing a highly intense activity, such as bouldering or sport climbing or lifting a heavy weight, etc. And the way in which our body can buffer that change in energy utilization is with what we call the phosphocreatine system. So three major energy systems that we utilize in order to produce ATP, the energy currency of our cells. Those systems are the phosphocreatine system, also the lactate system, so that's short-term energy without oxygen, and then the aerobic energy system, also known as the Krebs cycle or the citric acid cycle. And that's how we get the majority of our energy. So later on, we're going to be talking about a couple of different metaphors to hopefully better understand how we can utilize creatine and how creatine is utilized in our body. If we're looking at how the majority of our energy is produced and utilized, it's mostly through aerobic energy metabolism, which requires oxygen. So if we're looking at a car, aerobic energy metabolism is the gas that you put in the car. That's the true fuel for the majority of our cellular tissues. Then if we're doing a really short bout of exercise, so if I'm like an 800-meter runner, then I would be using predominantly that short-term anaerobic energy system, and I'll be producing lactate as a byproduct. But lactate is actually really nice because it's another substrate for energy. Now, the very, very short term, that is the phosphocreatine system's really wheelhouse for energy utilization. So intense mental activity or deadlifting maximally, things that are in duration between 10 and around 30 seconds. There we're really utilizing this phosphocreatine system because the other two systems, they do produce energy and they produce energy well. However, they don't produce ATP at a rate fast enough to be able to work with the very quick energy utilization during those very, very short-term activities. So very quickly, creatine is able to buffer the breaking of that phosphate bond off of ATP. So ATP stands for adenosine triphosphate. Adenosine triphosphate is the literal energy currency of our cells, and we get energy from ATP by breaking the bonds between that chain of inorganic phosphates at the end of that adenosine molecule. So adenosine triphosphate, we have 3 phosphates on ATP. If we break one of those off in order to produce energy or utilize energy, we are now left with an inorganic phosphate, a little bit of water, and we also have ADP, adenosine diphosphate. If we break off another one of those inorganic phosphates, then we are now left with AMP and phosphate. If we break off another one of those, then we are left with just adenosine. And adenosine is basically like a sleepy molecule. So adenosine naturally builds up in our brain and in our body. And when we have a large buildup of this, typically at the end of the day, then we get sleepy, we get tired. And actually, we have many ways for combating adenosine and its uptake in receptors. One of the ways in which we do that is with coffee. So be on the lookout. Later on, we'll definitely do a coffee episode. But today, we are on creatine. So how does creatine help us with this process of buffering energy and recreating ATP? So as stated previously, in order to utilize ATP for energy, we break the covalent bond between one of those inorganic phosphates and the ATP molecule. So that inorganic phosphate goes into the cytosol and it just gets floating away, and then we're left with ADP and that inorganic phosphate, which goes away. Now, in skeletal muscle, in neural tissue, in cardiac tissue, we are now left with ADP, which we can recycle back into ATP, or this is where PCR comes into play. We can take that inorganic phosphate that was previously shuttled away and attached to creatine, and we can use creatine kinase to break down the bond between inorganic phosphate and creatine, and we can latch that right back onto that ADP molecule, thus creating ATP again. So the more inorganic phosphate stored next to creatine we have, the better capacity we have to buffer short-term changes in energy, okay? So we are better able to do more short-term energy utilization with more PCR, more creatine stored in those tissues previously described. So the basic way that we can sum up how creatine works is that creatine, when it's stored in our muscle, neural tissue, liver, etc., cardiac tissue also is included in there, it's stored with inorganic phosphate, and when we break off that inorganic phosphate from ATP, we create ADP, and then we can take the inorganic phosphate from creatine to recreate ATP for further energy utilization. Now, there are also really exciting means by which the creatine molecule can buffer energy utilization in the brain itself. So later on, we're going to talk about special populations and why creatine might be important for people that have suffered from a concussion or a mild traumatic brain injury, because in mild traumatic brain injury, oftentimes these individuals are experiencing an energy crisis. So they have an energy crisis because oftentimes the cells have more leakage out of many of the molecules that are responsible for creating this concentration gradient between the inside of the cell and the outside of the cell. And we create action potentials and we excite cells by changing the concentration gradient, i.e. depolarization. However, when we have too much leakage of ions across that membrane, we'll have random depolarization, random excitation of neurons. And we try and maintain this concentration gradient by, you guessed it, ATP. We have to push ions across the membrane. So when they're leaking back and forth, we get too much excitement of neurons, which can eventually lead to a fatigue state of these neurons, a lack of ATP. Also, the mitochondria oftentimes get damaged and are unable to produce ATP, which further produces this energy crisis, and it creates this spreading like depression. We'll talk about that a little bit more later. So basically, creatine is a great way in which we can buffer the fluctuations in energy utilization. Now, who should take creatine? So, depending on what athletic endeavors you participate in, and actually depending on your dietary choices, this can alter who should take creatine. So, the number one individual or the number one subset of the population that should take creatine is probably power and strength athletes. So if you're someone who is engaging in rigorous and short, intense bouts of activity, such as weightlifting, short sprints, I would say rock climbing would be included in there if you're doing bouldering or intense sport climbing. These individuals are the prime candidates to take creatine. So with that, just supplementing oral creatine can be very helpful. Also, team sport athletes such as basketball players, soccer players, etc., especially if they're in the weight room for significant amounts of time throughout the week, they would also benefit from creatine supplementation. Now, with runners, it sort of depends. Sprinters definitely should be taking creatine, and this will help them not only in the weight room, but also with many of their interval workouts. Now, when it comes to endurance runners, this is one of the questions that we got. Is creatine beneficial for endurance runners? And we're going to do a separate Q&A session in which we answer some of the questions that we got through Instagram and answer some of the questions that some individuals asked me as well. So it depends on what kind of endurance runner you are. There's definitely a stratification of endurance runners, and some of these individuals may benefit from creatine, and some of these individuals may not benefit from creatine. And we'll talk a little bit more about how to take creatine. And then later on, we'll talk about special populations that really benefit, such as victims of concussion or mild traumatic brain injury and vegetarians, because vegetarians is actually a really big population that should be taking creatine. So if you're a vegetarian, keep listening to the end because you're really going to enjoy some of the information that we have for you there. But next, how do we take creatine? So with creatine, the objective is to saturate our muscle tissue and saturate whatever tissues we're trying to utilize with creatine so that we can store those inorganic phosphates and then use it for buffering when we create ADP from ATP. And by and large, the most common method of supplementation, what you'll typically see with creatine is 5 grams per day. And 5 grams per day is number one, a safe dosage to take. There really isn't an upper limit for creatine. However, individuals will often experience gastrointestinal distress, which we can talk about a little bit in why we take the amounts that we take a little bit later on. So typically 5 grams per day is adequate to increase levels of creatine. Now, oftentimes, in order to quickly saturate musculature with creatine, i.e. get the most amount of creatine possible as quickly as possible, individuals will do a loading phase of creatine. And indeed, many research studies will incorporate a loading phase. Why? Because it gets into the muscles faster. So we're just taking more creatine so that it gets into our musculature at a faster rate. And this decreases the cost of the study because then your loading phase can be 1 week in duration as opposed to 3 weeks in duration. However, at the end of the day, whether you do a loading phase or no loading phase, after about a month of creatine supplementation, the amount of creatine that's stored within the musculature is going to be the same. So why should you do a loading phase? You would potentially benefit from a loading phase if you want to load the musculature with creatine more quickly. So if you want to have a saturation of creatine within the muscles, then I would encourage you to do a loading phase. So if you want it by the end of the week, that would be beneficial. If you just go out and you take like 50 grams of creatine, then one, your GI system, your gastrointestinal system is not going to be happy with you. Number two, we can only absorb a certain amount of creatine at one time. And that's why that 5 gram dosage between 5 and 10 grams is kind of important, even during the loading phase. So instead of taking 20 grams of creatine at once, I would actually encourage you to distill and parcel out the loading of creatine to 5 to 10 grams multiple times throughout the day. So most commonly, loading phases, which will include about 20 grams a day, will include 4 independent boluses of creatine spread out in 4 different doses throughout the day. So 5 grams 4 times per day if you're trying to hit that 20 gram a day mark. And typically loading phases only last about 1 week. So 5 to 7 days in duration, you would take that 20 grams distilled into 5 individual dosages throughout the day. So 5 grams distributed throughout the day. Now, what happens when you take 20 grams at one time? Well, what's going to happen is you're going to saturate the receptors in your stomach and small intestine and large intestine for creatine. And creatine also brings water into our cells. When we're bringing a lot of water in and we're saturating receptors, this can lead to distension or expansion of the cells in our intestines. And this is one of the things that leads to that gastrointestinal distress that a lot of people will experience with creatine supplementation. So if you are experiencing a lot of gastrointestinal distress, then I would encourage you, even if you're trying to take just that 5 to 10 grams a day, to distribute that out through smaller parcels throughout the day. Because you may just be sensitive to creatine, in which case you might want to increase the frequency and decrease the individual dosage. So if you take that 20 grams at one time, then you're going to saturate receptors. When we saturate receptors, we aren't getting a higher rate of creatine absorption. In fact, what we're doing is we're really just increasing the amount of creatine excretion. So we're not even going through the normal mechanism of creatine to creatinine. We are just excreting creatine, typically through fecal matter and urination, etc. So it's not going to benefit you as much to take 20 grams or more than that at one time. And in fact, I would limit individual doses to about 10 grams per day. Now, on the flip side, there are some individuals who are quote unquote non-responders to creatine. And these are individuals that don't respond to normal dosages of creatine, i.e. that 5 grams per day. So in these individuals, it may be beneficial to increase the dosage so that hopefully you will saturate those receptors a little bit better than when you were taking 5 grams per day. So if you're a non-responder, then try taking a little bit more creatine, or creatine supplementation may just not be beneficial for you. So we have the amount to take each day, which is 5 grams per day for most individuals. Now, if you're someone who has a lot of muscle mass and you weigh over 200 pounds, in that scenario, it may be more beneficial to take upwards of 5 to 10 grams per day. Now, if you're a non-athlete, so if you're a sedentary individual, studies have shown that if you take as little as 2 grams per day, you're going to get a very significant increase in saturation of creatine within the musculature. So if you're a sedentary individual or you only do light exercise a couple of times per week, then as low as 2 grams may be beneficial for increasing muscular creatine stores. However, if you're an elite athlete, you definitely want to hit that 5 grams per day. So at least 3 to 5 grams per day. There have been multiple studies looking at the effectiveness of that low dose, the 2 grams per day, and it doesn't seem to be effective for athletes. Now, when we're taking creatine, are there anything that we need to take it with? And I'd say that the number one thing that you should take creatine with is exercise. Now, they don't need to be taken at the same time, but there seems to be an effect of exercise on creatine uptake and creatine utilization. And at the end of the day, we're trying to improve markers of exercise and improve markers of performance with creatine. So it just makes sense that creatine goes well with exercise. So exercise enhances the effectiveness of creatine, and creatine enhances the effectiveness of exercise. So we should be exercising if we're taking creatine, and we should really be trying to do more resistance training, trying to overload muscle tissues. And the way in which creatine works, back to the car metaphor that I sort of mentioned earlier, creatine works almost as if it was a small container of nitrous within your car. Now, I'm not a car expert, and most of what I know about nitrous is from watching one of the first few Fast and Furious movies. So if you're a car expert and I'm not saying this right, bear with me a little bit here. It's just a metaphor. So whenever we're in a race and we have a car that has nitrous, then from my understanding, you press the little red button, and this gives us a significant increase in the amount of power output that car is able to produce. So it's able to go much, much, much faster. And this is how creatine works. So it gives us that short-term energy storage for when we need to do very intense exercise. Now, how should we also take in that creatine? Are there different substrates that we should take it with? Water is effective. Coffee is effective as well. There is some equivocal data that says that caffeine may inhibit creatine, but by and large, this hasn't been shown to be consistent. So caffeine and creatine can be taken together without detrimental effects on your performance or detrimental effects on creatine itself and that creatine supplementation. Now, we talked about how to get creatine more quickly into muscles with a loading phase, that 20 grams per day that's distributed over 5 dosages during the day. However, taking glucose with your creatine can also enhance the absorption of creatine, as well as potentially enhance the absorption of and storage of glycogen in muscle tissue. So glycogen is really just muscle sugar. So glycogen is how we store more sugar within our muscles. And these things also have to be transported into our muscle cells. And it seems like the transporters for glucose and the transporters for creatine can work together in order to enhance the absorption of both of these molecules. So if you take creatine with carbohydrates, this may also enhance the effectiveness and quickness, if you will, of getting creatine into the musculature. So when we say enhance the quickness, at the end of the day, so at the end of that loading protocol, you're going to have the same saturation in the musculature. Taking it with carbohydrates may enhance how quickly it gets into the musculature, but at the very end of the day, at the end of that month that you're taking creatine, whether you do the loading phase, whether you do it with carbohydrate, or whether you do just 5 grams per day, these are all going to have the same effectiveness as far as saturation within the musculature. So there are different means by which we can increase the speed of saturation in muscles, but at the end of a 3 to 6 week period of time, all of these loading protocols are going to be the same. Great. So at the end of the day, they're going to have the same saturation in the muscle tissue. Now, let's start talking about special populations. And there's one special population that really sticks out as far as getting the most benefit from creatine. And that population is vegetarians. So the main food sources of creatine are meat products. And indeed, creatine is literally derived from the Latin creus, which literally means meat. So how do we get creatine in our diet? So if we're an omnivore, we get this from meat, chicken, and fish, okay? So vegetarians, obviously not eating a ton of meat, chicken, and fish. So these individuals have lower saturation levels of creatine and lower serum concentrations of creatine, etc. So if you are a vegetarian athlete, creatine would definitely be beneficial to take. And one of the reasons that creatine is getting a lot of interest recently is because of the potential mental benefits of creatine. And if we look at studies done on vegetarians taking creatine, number one, they get the most benefit in terms of power and strength. And if we're looking at muscle protein synthesis rates and adaptations to resistance training exercise and power exercise, etc., creatine is very beneficial for these individuals because it's going to but it's going to help saturate those muscle cells and actually help saturate neural tissue as well. So a lot of the benefits from creatine that vegetarians experience may actually, there's a theory here, may actually be related to supplying and filling in the gaps of a relative creatine deficiency. So in some individuals, vegetarians, we could look at creatine as almost a deficiency in vegetarians, and supplementation can fill the void that was once filled or could be filled with omnivorous diets or eating meat. So vegetarians benefit not only from the power enhancement and the strength enhancement and the benefits of resistance training with creatine, but a lot of the cognitive enhancements as far as increased focus, beneficial mood, etc. Vegetarians actually experience more of those benefits than omnivores. So right now, the enhancements in cognition and attention and things like that with creatine, they're fairly equivocal. Sometimes it is beneficial. Sometimes it hasn't been shown to be beneficial, especially at low doses for omnivores. But for vegetarians, these guys are more like, guys and gals, whatever, these people are more likely to experience the cognitive benefits associated with creatine supplementation, and it may be related to filling in a relative deficit of creatine. Because like we said, creatine is utilized as an energy substrate. There is literally the phosphocreatine system in our body, one of the three main energy substrates. So if you have a relative deficiency, then you are going to not be able to perform at your best for short-term energy, but also there may be effects cognitively as a result of being vegetarian. Now, the next subset and special population that may be beneficial to take creatine is for people suffering from a mild traumatic brain injury or so concussion, or individuals that are highly susceptible to mild traumatic brain injury. So American football players, potentially soccer players, here in the alpine, skiers and snowboarders, fighters, etc. Now, what happens with a concussion is some axonal shearing. So some of the neurons will get stretched out a little bit too thin. You'll also have some bruising of specific areas. And at the end of the day, we have the energy crisis that we talked about, which may potentially lead to overexcitement of those neural tissues because of leakage of ions across those cellular membranes, leading to random depolarization, basically random excitement of neurons. And this shouldn't come as a huge surprise because many of the symptoms of mild traumatic brain injury include dizziness, seeing stars, sensitivity to light, sensitivity to sound. So they're getting an enhanced reaction to normal stimuli. So an enhanced reaction to normal stimuli, what does that even mean? It means that I'm seeing this light that I normally see, but it's seeming really bright right now. A normal sound is being really loud and really affecting me. And this is due to enhanced excitement in those regions of the brain that are experiencing that excitotoxicity. So too much excitement can be actually somewhat toxic to the brain. And in too much excited states or states of too much excitement will release a neurotransmitter called glutamate. And this is deemed glutamotoxicity. And the end result is a spreading depression-like state. So just feeling out of it, fatigue, brain fog, headache, etc. And this is partially due to sometimes we'll get also a decrease in cerebral vasculature, so cerebral blood flow to the brain. And thus we have less oxygen. So remember, the main fuel is oxygen. The main means by which we produce energy is with aerobic metabolism, utilizing oxygen. So if we have even a minor reduction in blood flow to the brain, we will not be able to produce energy at the same rates as we previously were able to. And this can last for a couple of weeks, a couple of months, or in some individuals, they will have significant long-term lasting effects. And the way in which creatine can benefit these individuals is by increasing the amount of creatine that's in the neurons of the brain. So it can buffer and somewhat assist with this energy crisis by giving us more inorganic phosphates so that we can recreate ATP without oxygen. Now, there really has not been done a lot of studies regarding creatine supplementation in these individuals. There have been a lot of animal studies where creatine loading shows a fairly significant amount of benefit. For ethical reasons, you obviously can't load someone up with creatine and then give them a head trauma. So unfortunately, they do this with animals. So they've studied mice and other animals. They've loaded them with creatine, and then they've done a situational head trauma. And these animal studies show that there are significant decreases in the severity of the symptoms associated with mild traumatic brain injury. Now, in the human population, they have started some supplementation in some hours after a traumatic brain injury or a mild traumatic brain injury. And in these studies, they have also shown some benefits related to frequency and severity of headaches, as well as frequency and severity of fatigue-like symptoms, and some benefit to photosensitivity, so sensitivity to light and sensitivity to sound as well. However, getting creatine into the brain with supplementation is an uphill battle. And the reason for this uphill battle is due to this special barrier in our brain called the blood-brain barrier. This blood-brain barrier is very important and beneficial to us because it keeps some things that are circulating normally through our blood out of our brain. So then if bad things get circulating within our blood, like an infection or some other toxins, they are much less likely to affect our neural tissue because of this blood-brain barrier. And this blood-brain barrier is created by our supporting glial cells called astrocytes, and they're these specialized portions of our astrocytes called our in-foot processes. All that stuff is not quite as important as the fact that we have this blood-brain barrier. And creatine, more often than not, is unable to cross the blood-brain barrier. So only a very small amount of creatine is able to cross the blood-brain barrier in responder populations. So not only is it difficult for creatine to cross the blood-brain barrier, but even if we are a responder, it's still only a small percentage of that creatine that crosses the blood-brain barrier. So if you are an individual that is experiencing a mild traumatic brain injury, number one, go see your physician, go see your healthcare provider, because they're going to give you a lot more advice than just take creatine, okay? But I have utilized creatine supplementation in some of my patients, and some of them do experience benefits. Some of them are really good responders to creatine, and then some of them are likely non-responders. However, in order to try and mitigate that uphill battle against creatine getting into the brain, we typically have to significantly up the dosage of creatine. So instead of taking 5 grams per day, we're taking 5 grams 4 times a day. So we're really just continuously loading creatine with a loading protocol so that we can supersaturate the serum volume of creatine as well as the musculature, so that we can hopefully increase brain saturation and neuronal saturation of creatine. Now, the data are equivocal regarding neuronal saturation and neuronal increases in creatine, and this is potentially due to the non-responder population and how creatine is measured in the brain. But there are some studies that indicate that we can increase creatine concentrations in the brain, but that dosage just has to be quite a bit higher. Creatine can be very useful as a short-term energy substrate. So when we're taking creatine, we're literally taking a substrate for short-term energy. And this is especially important in tissues that experience significant energy fluctuations, such as cardiac tissue, neural tissue, and musculature, so muscle tissue. Creatine helps us and aids us by buffering those big fluctuations in energy, by taking those phosphocreatines, those inorganic phosphates, and then replenishing our ATP stores. So how does the body use creatine? We talked about how our muscles will store creatine and our neural tissue will store and synthesize creatine in order to mitigate the fluctuations in energy utilization. The people that benefit the most from creatine are going to be strength and power athletes, as well as short-term sprinting athletes, whether they be swimmers or runners or cyclists, and even team sport athletes would have some benefits. Now, special populations that would benefit from creatine include vegetarians and those that suffered recently from a mild traumatic brain injury or concussion. We talked about optimal dosing during this podcast, and optimal dosing is about 5 grams per day if you're under 200 pounds of body weight or if you have normal musculature. So if you have very, very high amounts of musculature and weigh over 200 pounds, then you may want to be on the higher end range between 5 and 10 grams per day. If you're a sedentary individual, then 2 grams per day may be beneficial. But if you're an athlete, then you're going to want to increase that dosage to at least 3 to 5 grams per day. Now, if you're looking for getting creatine into the muscle tissue and saturating your muscle tissue within 1 week really quickly, then an loading protocol would potentially be beneficial. And this would be about 20 grams per day distributed in 4 5-gram doses, equally distributed throughout your day. I hope that this podcast and this deep dive into creatine was beneficial for you. Thank you for listening to The Art of Prevention. This program is for informational purposes only and is not intended to be a substitute for professional medical advice, diagnosis, or treatment. Always seek the advice of your physician with any questions you may have regarding a medical condition. Always consult with your physician before starting any exercises or doing anything contained in this program. Always stop if you experience any pain, discomfort, or difficulties performing anything described in this program.